So let's try solving for linear homogeneous equations with constant coefficients. Okay. The first example, y double prime plus y prime minus 2y equal to 0. So nata idea daan basta ingani ganing differential equation mo ni pinakasayon i-solve, di ba? Because ato lang siya i-transform into a polynomial quadratic equation. Y squared minus lambda squared minus lambda minus 2 is equal to 0, and our lambda or roots are equal to -1 and +2. So as per the cases, this is case 1. So i-substitute lang natin dito sa formula. Our final answer, YH is equal to C1 e to the power of -1x or -x plus C2 e to the power of 2x. Final answer. Another example, y double prime minus 7y prime is equal to 0. Okay? So, unsa man lambda squared minus 7 lambda is equal to 0. So, our lambdas are equal to, unsa man nga case? Case 1 gyapon, because 0 and +7 atong lambda. So, itsura sa atong solution would be C1 e to the power of 0 plus C2 e to the power of 7x, or C1 plus C2 e 7x. Final answer. Let's tag another case. Diba? Y double prime plus 4y prime plus 5y is equal to 0. Characteristic equation, lambda squared plus 4 lambda plus 5 is equal to 0. Now, using our calculators, our lambdas or our roots are -2 plus minus I or j. J. So A is equal to -2, B is equal to 1. Using the formula, this is case 3. Okay, complex roots. Our final answer will be equal to C1 e to the power of -2x cosine 1x, meaning cosine x, plus C2 e to the power of the same -2x sine 1x or sine x. Alright. Another example, or last na siguro ng example kay sayo naman po gid ni, di ba? Y double prime plus y prime minus 2y is equal to 0. With initial value conditions, y at 0 is equal to 4. Now, unlike first order differential equations, na isa lang you only need one initial value to solve for the arbitrary constants. kay second order siya, we also need 2. No? So, ang first na initial value is y is equal to 4 when x equal to 0. And the first derivative of y when x is equal to 0 is equal to negative 5. Okay? So, initial value conditions. Using this one, ato na lang diretsyon iyang roots ani kay lambda squared plus lambda minus 2. The roots are 1 and negative 2. 1 and negative 2. So our y is equal to c1 ex plus c2 e negative 2x. How do we substitute or solve for the arbitrary constants? Tungod kay we have y at 0 is equal to 4 and y prime of 0 is equal to negative 5. Ato na i-derive, no? So y prime of h is equal to, as is, c1 ex plus negative 2 c2 e negative 2x. This is our equation 1 and equation 2. Okay. Substituting y is equal to 4 when x equal y is equal to 4 when x equal to 0 and y prime is equal to negative 5 when x is equal to 0. Atong ma-reduce ang atong linear equations into 4 is equal to 4 ni siya when each of these are zeros. So c1 plus c2 and negative 5 0 1 1 c1 minus 2 c2. So simultaneously solving for c1 and c2 using elimination, no? minus this becomes 9 is equal to 0 plus 3 c2. Therefore c2 is equal to 3 and c1 is equal to, if c2 is 3, c1 is 1. Therefore, i-substitute natin ibalik sa atong kane, y of h. So our final answer would be e to the power of c1 is 1, so e to the power of x plus 3, c2 is 3 e to the power of negative 2x. Our final answer. So ingan ni dahil basta na initial value condition, no? Makuha nga homogeneous solution is i-derive and then substitute the initial value conditions here and replace all x's with zeros. Okay, 0 man ni dire na may times nga dili 0 initial value condition. So sa atong lucky nga problem nga 0 tanan x's, so mga wala ni tanan is, that's why we are left with this one. And simultaneously solving for the variable c1, c2. This is the final answer. 3 and 1. Substitute balik sa original equation. This is our final answer.